Yeah.
They, them, whoever. Whoever, we are open to everything and everyone. So okay. All right. Yesterday in our session, we did. What was it? What do we go? What?
Ionic equations?
Ionic equations. Yeah, that's the one. And guess what we're gonna do today? That is about right, unless y'all feel very comfortable with topics at hand and would like to do something different. What would you like to do, sir?
It's, I mean, I had it.
So is that
It was like calculating, like they just give you like molarity and milliliters. And then you have to like make the net ionic equation and then go to, it was like one of the Alex topics.
Interesting.
And then you have to like calculate, I'll pull up this.
All right, in the meantime, let's see if you all remember what we did yesterday. And try number 8 by yourselves. While this gentleman pulls up his thing. Oh, are you having trouble with those?
Yeah.
wait, what's the topic name on it?
You really just need to find the limiting reactor.
That's it.
Yeah,
Oh, for God's sake, no.
those are,
Just spam 0 until you get it.
no, that's not good advice. You need to
No,
know that-
yeah, because I saw, like, I would click on the explanation and saw that sometimes it'll just be 0. That's why I was confused.
Yeah, solve, what does this say? Solving limiting reactant problems in solution.
It's bounding you can.
Do you not know how to, have you tried it yet?
I've tried it a few times and just like, you know, it does not make sense.
Yeah, so all you have to do is figure out the reaction, what happens. So zinc iodide is potassium carbonate. You should get potassium iodide. Find the limiting reactant. And then you need to find the excess. Oh, look it. Potassium iodide is soluble.
Yeah.
Therefore, the concentration of I minus is the total concentration, like is all the I there. Because there's no precipitant.
Yeah.
Therefore, you find the. Yeah, I don't know how to explain it. Without showing you the math. Because there's no, because iodide does not show up in a precipitate. Therefore, I minus is going to be all in solution. So whatever I minus you have at the beginning is going to be at the I minus at the end.
So just do 2
So-
All right, change that to grams.
So
Divide by,
find the moles of iodide or iodide in solution and then just divide by the liters of. In this case, because there's no precipitate.
okay.
So what should you say about these two positions?
So I tell you, I fixed my exam grade.
What is it then?
It's a 200.
Oh, Ben. What do you do? Grab a teacher?
What?
Grab the teacher?
Yes, that's what exactly.
Something like that. All right, we should be done with number 8 by now. And hopefully, if we are, and if y'all are comfortable, we can move on to something more different. So what did y'all get over here for number 8? Coefficients and everything.
Oh, you can write it out.
Oh, no, we didn't balance it. It's like rule number 2.
She literally just figured it out, just didn't write it all out.
All right, so this is what kind of reaction? Double. There's a double displacement, so you get the potassium goes with the nitrate, so KNO3. And nickel 3 bromide would be Ni. Are now we need to assign the what's it called? Physical states. So is potassium nitrate soluble in water? So it's aqueous. What about nickel 3 bromide? Why is it not soluble? Okay, say it with your chest.
Kidding, I'm just kidding.
Is it soluble or no?
No, well, yes,
When you put it in water, it dissolves.
yes, it does.
That is correct, because
That's water.
bromide, is it Br minus, Cl minus, and I minus are generally soluble, except when they are connected to copper +1, mercury 1, so Hg2, 2+, lead 2+, and silver. These are the exceptions for your halides, not including fluoride. So therefore, this is also soluble, which means what? What? Everything is soluble in water, and if everything is soluble in water, is there a reaction that occurs? Oh, not really, because there's no precipitate, and there's also no reaction, because if you do the net ion equation, everything cancels out, meaning everything's in solution. Like K plus, NO3 minus, nickel 3+, and Br minus stays in solution, just as it is on the left side. Therefore, nothing, absolutely nothing is involved in a reaction. So what do we say? What? Yeah, because look at Ni, yeah,
What do we after this?
okay. So what do we say when everything cancels out? Is there a reaction that happens? Therefore, we say no reaction. Perfect. All right. So what could we do now? How do y'all feel about this idea? We want to do, you want to make up some other ones that we can work on, or you want to go work on like number problems? The math.
The good stuff.
This exam is the most math heavy exam you're gonna get this semester.
Yeah.
So if you're not comfortable with the math, then you're not gonna be comfortable with your grade when you get it back.
Pretty much, yeah. Exam 2 is like mostly math, and then exam 3 is like mostly conceptual stuff.
So you want to start practicing the calculation stuff, or you want to stay on the conceptual side of exam 2? Math, all right. Give me 1 second to get the math part. I'm sharing my screen. Exam 2.
Remembering.
All right, let me share my screen. And everyone, please try these problems. You're only gonna do yourself, you're not gonna do yourself any favor if you just go with what I'm writing down. So try the problems. We'll give you number 2. We'll give you 3 minutes to work on number 2. Try to get as far as you can go. And if you get stuck, keep going until we reconvene. So 3 minutes starting now.
This specific worksheet I'll send out probably this weekend in an email. This is like our exam review, what we're gonna do. We need to change up some of the questions, but
Yeah, we need to add some questions too. with your mentee? What do y'all do?
Talked pretty much.
Talk about what?
It's YouTube channel.
This guy has a YouTube channel?
Oh, he agreed to edit our videos, by the way.
Oh, wait, bro.
Since send him over to be on edit.
Quality production about to go on.
It's about to go up, bro.
Oh, yeah, it's about to go off.
Maybe we can have him do like the, like different question. I don't know how you break down the thing, so it has like timestamps or something.
Yeah,
Tell him like question 9.
I might like actually cut stuff out, because I don't, cut stuff. I edit, but
Yeah.
I know how to, I'm just too lazy. to do it. That's my thing.
So like he would be editing out this portion right now.
Yeah, the part where it's just like we're talking about things that don't matter.
Yeah.
That
exactly.
too, and also the part where I give y'all 3 minutes.
Yeah.
Yeah, that too.
Or we can just be like, pause the video. Yeah. That's what Welcome to does.
Yeah. OChem tutor teaches a little slow. Great.
No shade towards Welcome to.
Shout out OChem tutor. Maybe if he shouts us out.
I love it. I love it.
I don't want to disturb.
Oh yeah, we have 2 more minutes.
The Ocam tutors are perfect. Right? You can do no wrong.
Maybe you should leave our session now.
We are too, but I was gonna say cyclical pain instead.
All I'm saying, guys, more subscribe.
Problem the other day, he's like, solve this.
Oh yeah,
Teach me gentle, when I totally forgot.
go sit in the back, that's your spot. I'm just-
Yeah, I was like,
Failed my last time.
what was it? It was like methyl. Yeah.
So you got the points back, though?
I got the points back, bro.
Congratulations. You got good, man?
Yeah.
Yeah, I was being stupid.
Seven people got a perfect score on that.
1 more minute, guys and girls, and
That's still good. Yeah. Better than when I go to my bus test. Yeah, I just made dumb mistakes, that's really it.
65. 2007 every other week.
You gonna retake it or just leave it?
all right, guys, it is time. Who was able to solve it? And did you get the right answer? With your fingers, and this is a decimal point. Show me your answer. I get it, yeah? Okay, that sounds about, oh, too many stick figures, bro, come on,
I would just do 0.1 then.
go back to basic, I'm just kidding, I'm just kidding. Okay,
Alright, like to this point and like beyond, he doesn't really
care about.
care about
stick
sig figs. It's like 2 to 3 is like an accepted number, like range.
Yeah, I usually go to like 1 decimal point, especially like if the second decimal point is just a 1 or something, like it doesn't, but yeah. And also, like the problem here has 2 figures, not that it matters. But some, okay, anyways, what's this problem asking for?
Concentration of HI.
Concentration of HI, and concentration is measured in what? Which is molar. Yeah, molarity. So we want the concentration of HI, right? So I'm just gonna abbreviate that, molarity sub HI equals the moles. Moles of what? Well, we're solving for the molarity of HI, so we need the moles of. We need the moles of HI, there we go. Perfect. If we're solving for the molarity of HI, it wouldn't make sense that we need the moles of barium hydroxide, right? Good. Now, divided by the liters of solution, okay? So L. Okay, this is what we want. What are we given? We are given the liters of solution. Or what is the liters of our solution that we're concerned about? what's the volume in liters? Or what's the volume that they give us that we're gonna use to solve for the molarity of HI?
Oh, well, they get 42.5 now, so it's
Yeah.
0.0.
Yeah, so a lot of people might make the mistake of adding these two for the entire solution. Exactly, so if it's specifically asking for the initial or the original concentration of the HI solution, then we need to use only the original volume for that HI solution. So in this case, 42.5 mils. So our L is equal to 42.5 milliliters, but we need it in liters. So this is 0.0425 liters. Or yeah. All right, are we good so far, my fellow chemist? So we got liters and we're looking for M molarity. We only need one more variable, so we need moles. So that's the question. How are we going to find the moles of hydroiodic acid?
You can write a balanced equation, change the molarity of barium hydroxide to moles, and then
Okay, so I see where you're jumping ahead, definitely. I'm gonna first one step at a time. So first we should write a balanced chemical equation, like you said. Oops, sorry, fellas. So BA, what kind of reaction is this, by the way? What? Double displacement, but more specifically, we have what kind of reactants? Acid-base reaction. And these always form salts and water, right? So we get barium iodide and H2O. Physical states, we can assume, well, everything here except the water is soluble in water, if that makes sense. So aqueous, 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 and liquid. And here we have, now we need to balance this. So
the 2 in front of the I and the 2 in front of the water.
the 2 in front of HI and 2 in front of water. You balance it out. All right. So it doesn't give us the moles of hydroiodic acid, but what does it inadvertently give us that we could use to get to moles of HI?
The ratio between hydroiodic acid and barium hydroxide.
Exactly. So it gives us enough information to figure out how many moles of barium hydroxide we have. And we know if we have moles of one reactant, we can get to moles of another reactant using the balanced chemical equation. So let's try that. So to get 2 moles of barium hydroxide, this is going to be molarity equals moles over liters. The liters here is 0.0569. And our molarity is 0.79. Right, so plugging everything in and so let's rearrange this first. So you get molarity times liters equals moles. Plugging everything in will give you 0.79 molar times 0.0569 liters equals, it should equal 0.04495. Yeah. Read this there. 0.04491. And this is in units of moles of barium hydroxide. So moles of BaO2. Perfect. And we have the moles of one reactant. How do we go to moles of another reactant? People in the back. How do we go to moles of another reactant? Molar ratio from where? Balanced chemical equation. Exactly. And the way for this one, it's 1 mole of barium hydroxide it requires 2 moles of HI to react. This should give us a nice number of 0.0899 moles of HI. Okay. So guess what we have? We had our missing component, which is our moles of HI. We are already given our liters of solution, so all we need to do is plug into this equation now. So molarity HI equals 0.0899 moles of HI over 0.0425 liters. I'm plugging this into an amazing handy dandy calculator and taking into consideration significant figures. It should be 2.1 molar HI. I know I say he doesn't really care about sig figs this exam, and that's true, but I always have, I go with sig figs on this worksheet because there's always going to be a student that says, shouldn't it be 2 sig figs? And I'm just like, yes, in this case it should. So I always go with sig figs when we're teaching it, because 1, it's the right thing to do, I guess. And 2, I don't want anyone to ask me, and shouldn't it always be, anyways. Sorry, I'm just ranting. How do we feel about that one? Are we able to do it by ourselves?
No.
Okay, and you think with more practice, we'll see it, like you'll find a pattern and see how to solve these problems?
Probably. Do you think we could do more like practice problems, like similar?
Sure. We got another one, number 3. You can go ahead and try that one next. I'll give you all 3 minutes. Try it. If you need to, if you get stuck, try to glance at the notes that we just took on that previous problem. And in fact, before I show you that one, I'm gonna say, what was our steps we took? So I'll highlight them in different colors. So step 1 was this portion here. I guess give me 1 second. I'll show you the problem in just 1 second. But step 1 was all in red. And this is identifying what we're looking for. So I'm really just going to circle what we want, because that's exactly what this step was all about. So step 1. And this is like honestly how you solve any problem. What are you looking for is the big question. Secondly, our second step was, let's do this one in blue. Write our equation. And step 2. And then our third step was orange. We figured out moles of one thing because we realized from using this equation that if we have moles of one thing, barium hydroxide, we can get to moles of HI because that's what we want, right? That's what we figured out we need in step 1. And step 3 is all about finding those moles of HI, which is our goal here. And then step 4 was this one, plug and chug. So try to go in those same 3 steps for the next problem, okay? So I'll go back to it. There you go. I'll give you 3 minutes starting now. It's 3 o'clock at 3:03.
You have a couple of events this afternoon.
Nice.
Scott Dillon, pre-booked.
500K for sure. Try to follow like bar for bar, like this is the step 1 that I was talking about, like what do we want? What are we looking for there? Then step 2.
All right, I'll inform your methods for now.
Remember, we're trying to get this ingrained in their minds. I'll stamp you like a cow.
Oh, that's crazy to say.
Please edit this out, by the way.
Yeah,
Anyways, I have an answer.
let me see the answer key.
I didn't write them on the sick fix too.
That's the one, that's the one. Why are you not boxing your answer, man?
Is this Carmon?
Make sure you box your answers when you take home.
No, I do on the
Okay,
take-home.
good.
Yeah.
Yeah,
Because some people don't, and it's like a scavenger hunt.
No, I box it in and I highlight it.
some people embed them within their explanations, so I gotta like look through all that stuff.
I highlight my answer both in like my work and the explanation, so like you know which step is the final one, because y'all go through like what, 100 plus.
Yeah, something like that.
I mean, from
The
what,
people that actually turn them
from what I've seen, yours are pretty organized.
in. Yeah, I try.
Thank you for that.
I do it for the people.
No. I'm not good.
You know what the worst part is? There was one that I forgot to turn in, and I really filled it out, and I knew I would have got 100.
Have you requested your Alex one yet?
Why?
Have you requested your Alex ones?
Yeah. I don't have that many. I kind of just stopped doing it.
I mean, you should request them.
Can do that.
I'm probably gonna
Use
knock
it
those
for a
out
take
today.
home assignment. It's 15, right?
Use it.
No, take homes are 10, and then I could.
I never asked.
How did you do on the last?
No, wait, the exact same.
On the last.
But there's no point in ever doing an iClick.
No, no, Arbonne has a love affair with iClicker for some reason.
No, he really does. I don't think we've done anything else in class besides iClick.
Terrible.
Like, what is?
No talking quiz.
Above 50, below.
I love how every single one is like, yes, you can have a calculator.
What about you?
Above 50.
But it's good though, you like ask the questions like how he's gonna ask them.
But the
Yeah,
thing is,
that's true.
it's the bad
I don't know. I kind of,
I really do.
it's
know
different
what's-
from what I'm used to. I do think I still prefer like,
Really?
Yeah.
What's the answer to that?
and like lecture hall being like, for actual like teaching and working through problems in person. Cause like video assignments are loose.
Yeah.
But they're not.
Without further ado.
Welcome to college, bro.
Yeah.
Like me and this guy, I don't think we pay attention to them at all.
Oh, no, I don't pay attention to that class.
I know y'all don't. I played Serato, but
I mean, we teach ourselves most of the material.
That's how it is.
Point being, yeah.
I've been playing Serato at Monts for a few days. It's great. Got a lot of trophies.
If you think you're not gonna learn much in Dr. Armand's class, wait till you get your Gen Chem 2. Even worse. Today you're gonna have to be studying all by yourself.
Just hope I'm in Austin by that.
Well, you're a Kappa?
No, I'm just transferring regularly. I don't want any risk of going, like, if I can't get in like with my regular major, then there's no point. Like, I'm not going into liberal arts.
Imagine some biochemistry, turns into an art major.
This guy really pulled a Yusuf from biochem. Great.
Who's Yusuf?
Yusuf was like a friend of mine last year.
Oh, what?
He was one of my students last spring. What do you use? I think he got to 60.
Either I get in this.
Okay, Mitch.
You get in this.
Rich, it's been 4 minutes.
4 minutes, all right, I gave you an extra minute because I'm nice.
Thank you.
So what is the molarity of a KOH solution if 86 milliliters needed to neutralize 42 milliliters of 0.276 molar HCl solution? What is our first step?
Right about.
That should always be your first step. So potassium hydroxide plus HCl, what will be our products in this case?
Potassium chloride and water.
Potassium chloride, water. What type of reaction is this?
Space.
Yeah, this is an acid-base reaction. Acid, what's our acid and what's our base?
The acid is hydrochloric acid and the base is potassium.
And then are these strong or weak?
They're both strong, aren't they?
Both strong, yeah. There's a strong base, strong acid. All right. Now, this is like a little tangent I went on, but basically now we're gonna see what we actually want. So we want the molarity. What's molarity equal to again?
By what?
Moles per liter.
Yeah, sounds about right.
Moles per liter. And then, so you notice, right, we have some type of milliliters of HCl, and we have some amount of concentration for HCl. So what we can go ahead and do is this. We can say 0.276 equals the amount of moles, that's what we don't know yet, times our volume. It's 42 milliliters, but do we want it in milliliters? You need to convert to liters. So what I do, I take the 42 divided by 1,000. So that's looking here, that's 0.042. You solve this out, right? Your X will be equal to 0.011592 moles of HCl. So this right is our moles. And what do we know about our moles of HCl in relation to our moles of NaOH for the equation? Exactly right. It's a 1-to-1 ratio. So this also equals the moles of, sorry, I said NaOH, this is KOH, potassium hydroxide. All right, so now we have this. So what we do is we need to find the molarity. Well, that's good because we already have the volume right here. So all we're going to do is 0.011592 over, again, we need it in liters. So 0.086, so moles per liter. And if you solve this out, you get 0.135 molar. So that's our final answer. All right. Any questions on that?
So like anytime they ask about like, or they have like this kind of format, you have to automatically think like balance equation and then like the rest of the steps.
Yeah, so
Yeah, it's pretty much like it's a series of steps, right? Like there's a systematic approach to it.
So, like before, we started with step one, which was identify what the question's asking for.
Yeah.
Right? And identified what missing component was. So in this case, the missing component in what we needed was the moles of HI. So we needed to find moles of HI because we had the liters and we were looking for molarity. After step one, we go to step two, which is what is step two?
Step one was find what we needed, right? And step two should be the equation.
Yeah, balanced chemical equation, right? And then once we figure that out, we look at our relationship between like the moles of barium hydroxide that were given to us, right? And we realize we can get to moles of HI with this equation. So if we find moles of barium hydroxide, which we did, using the molar ratio 2-to-1, we get the moles of HI. And then from there, we go to step 4, which is just plug into our molarity equation. What? Plug and chug, exactly.
Pretty much the same set of steps every time. You just have to watch out for like what you're given. Like maybe if you're asked for volume and you're given like molarity and moles, then they'll ask you to like solve out for that. Basically, they'll give you 2 out of the 3 variables and ask you to solve for the 3rd one. Or if they don't give you one directly, they'll give you how to calculate it. Like say, for example, they give you grams, you know that you get moles by using mole mass. So yeah, that's also another way they can phrase stuff.
Pay attention to units.
Yeah, pretty much. All right, this is gonna be like a quick one, like 5 seconds. The reaction of silver nitrate, sodium chloride produces sodium nitrite, silver chloride. Is best classified as what type of reaction? Y'all in the back, what are y'all thinking? I mean, yeah, it is, but like,
Oh,
what is it more specific?
Wait, what are we looking at? 4 or 5?
Number 4.
Wait, what did he say?
What type of reaction is it? It is, but like there's a more specific way to refer to this.
Oh, it's like the other name for it, is that what you're saying?
There we go. Look at what Sophie said.
Oh,
Right,
said that.
Sophie, you're right on the money, it's is a precip.
But it's the type of reaction.
Like if you put double displacement, you'll get it wrong, it's precipitation reaction.
Options.
There's only like single replacement, acid base reaction, combustion reaction, double displacement, precipitation. Is that like five? That's five answer choices.
Yeah.
That's a thing too, but we'll go over that.
That is a thing too. Honestly, we don't care about redox reactions until you get to electrochemistry.
Yeah, balancing, we want to balance on the agenda too. All right, well, why would this be considered a precipitation reaction?
If AgCl creates a precipitate, or AgCl is a precipitate.
Yeah, so this part, right, is a solid, so that's why it's a precipitation reaction, you make a solid. And here's right where you can do your like net ionic, total ionic, all that stuff we were doing yesterday, that's where this comes into play, for these types of reactions. You can also do them for acid-base reactions, by the way. If let's do this. HCl plus NaOH
You just.
makes H2O and NaCl.
Wait, the first time.
What is the net ionic equation for this reaction?
H plus OH.
Exactly. That's the case for any strong acid, strong base reaction. H plus OH minus makes H2.
Two of them are mean.
All right, y'all good on that? Y'all understand why it's a precipitation reaction? Zoom people, let's get a Q if you have questions, an N if you don't.
We will.
Next.
We just don't want to do it now.
Bring paper so you can do your own.
No, she's getting her iPad back.
And then you bring paper
I
then.
have.
We got N on N on N. Okay,
She doesn't want to do work. No,
Number five.
I'm kidding.
assign oxidation numbers to each element in the
I
following.
guarantee this test grade will go up by the.
So what are oxidation numbers?
My issue. I'm just.
But when you're so comfortable with the material, the test becomes so easy.
It's not kind of second.
I used to think I had testing anxiety, but then they were prepared for the exam.
What the oxidation.
I actually studied.
What's an oxidation number, you know? I mean, how I like to think of it is like fake charge.
Like, I think.
Like, it's more like a representation of like like what
39.
happens in the reaction. Like, you know how like bromine has like a -1 charge, but it doesn't always that way.
That was a low.
Oxidation numbers explain like the behavior and every specific. That being said, this thing, OF2, what will be our oxidation numbers?
Just remember.
Like, during the 3-minute period, I gave you to solve the problem.
Isn't fluorine always -2 or -1? So
Yeah.
oxygen's actually
And
positive
that's
too.
maybe.
This is actually one of your
maybe it's
exceptions.
'cause you want to
Yeah.
run drainage.
Fluorine, right, is -1, and then oxygen is your
Get to a
+2.
roadblock.
If this oxygen has a +2 charge, you think this is like a stable compound or not?
That's all. You're like, oh, so next time I run into that same roadblock, I know
Does,
how to go.
think about the charge oxygen normally has. Yeah, and you see how -2 and +2 are like a big, like, there's like a big gap between those.
Solution.
That's a whole like 4 electrons. You know what I'm saying? Like, so basically OF2, this isn't like a very stable compound.
Well, we need to know like the stability of compounds.
I'll tell you get to OChem. It's mainly where you'll see that.
So like you would just be able to tell off with like the different oxidation numbers.
You want to A? Are you all treatment?
All right, this one, what's that called again?
Hydrochloric acid, or just chloric acid, perchloric acid.
There we go, perchloric.
Sorry.
I finally got it.
I knew what it was, I see the hydrogen, I always think hydro, but I know it's not, it's polyatomic.
Perchloric acid.
Like.
All right, let's assign oxidation numbers.
Hydrogen's +1, oxygen is -2, but since there was that thing. Chlorine is.
They're like either 100.
+7.
I don't know.
Yeah, this isn't a stable compound either. Like, you actually need what, a special permit to buy like perchlorate. Here, I'll do this thing. Cause
And also they let you buy sulfuric acid on it.
sulfuric acid is not that bad, like, you have a +7 on a chlorine, it's this bad. Like, apparently, it like eats up like everything in your hood, and your hood smells like Swiss cheese. This is what I've heard though. Like, this stuff,
Not the worst.
Isn't
thing.
bleach.
Tell everyone what problems we're going over.
hypochlorite. Bleach is actually sodium hypochlorite.
Try
So-
that before the session.
Yeah, there's actually
That way
like,
now,
+1 isn't as bad as +7, that's why you're able to isolate it, things like bleach.
What if that's what I did? And they're over here telling me I need my.
Alright, what about C, what is this thing called?
It's in my.
Yeah.
I'm just kidding, I'm just kidding.
Right.
That's how you spell that.
Acid. It is gonna be the same thing, but we're gonna
Alright.
send it
Yeah,
out
that's right.
later. All right.
Now, James, what are our oxidation states here?
+1.
Yeah.
And then oxygen is still -2. Seven, right?
Yep, +7. Basically, all you need to do is just get them to atoms to 0. And manganese, right, +7 on a manganese is okay, because it could have like multiple charges, one of them be +7, so, yeah. All right, what about this bad boy right here? Used in a lot of biological reactions.
Phosphorus is +5. Oh, that's phosphate, but phosphorus is +5, oxygen is -2.
Phosphorus, or -2, let's do this one first, so -8, and then +5, right, because we need to get into that 3 - 8.
You don't want it though, I'll take it.
Yeah, that's crumbled up though.
Okay, it's like a little powder. Oh, wow.
All right. Well, how did you name this?
Just arsenic acid.
Arsenic acid.
ESO3.
Well, what is the polyatomic ion on arsenate?
Oh, it's ASO4.
So what would this be?
Arsenous acid.
Yeah, R, so I spell that.
ARS.
Arsenous acid. That's how you spell that. All right, now let's get all our oxidation states.
It's worth it. We're after what, for sulfur?
All right, Zoom people. All right, arsenic is +3. Then our oxygen obviously -2, and then our hydrogen is +1. All right, y'all get the hang of this. Basically, you need to make everything 0. Oxygen's -2, except in this case right here, we'll have 2. Then hydrogen's usually +1, but it's -1 when bonded to atoms. Yeah. All right. Zoom people, tell me the oxidation states for this one. Name it and tell me the oxidation states.
Oh, yeah. It's right there. Ah, I'm sorry. No, that's the one thing that's from cells. Usually I just throw it at the teacher.
Yeah, don't do that.
I don't want to get banned.
Hmm?
I don't want to get banned. I
And,
might show up once in a blue moon, but you know.
All right.
all right. Sophie got her money up, as they say. So she said it was antimony fluoride. Yeah, and antimony is one of those metal woods. So. Yeah, I'll accept it. Antimony fluoride. We don't know if it's a metal, we don't know if it's non-metal, so fluoride, right, -1. So -6, and then your antimony is gonna be +6. Exactly right. All right. James, what are we thinking for L? Aluminum oxide, right, that's the name. What about our oxidation states?
So oxygen is still 2-, right?
Yep.
And then aluminum is
Yeah, plus 3, because there is total of 2 of them, so you have to divide by 2.
I
Minus
have a
2.
question on the one before. So
Yeah.
I think they said something like, when you name metalloids, you sometimes have to approach it as if it's like a covalent, like molecule or something.
I mean, yeah, that's why I said I'll accept it, because it's like,
So then
Wouldn't it be
hexafluoride?
Right, yeah.
sometimes you gotta, I don't know, it could be a metal, sometimes it could be a non-metal sometimes. Let's pretend that you use covalent naming scheme and say it's hexafluoride.
Might have to remove the check.
Antimony doesn't have a normal charge either, so you wouldn't be able to tell just by antimony fluoride.
You know the molecular geometry of that? So, hopefully by the end of the semester you do.
You'll learn it by the end.
Is it interesting?
It's not as interesting as some alkenes, but this is definitely pretty interesting.
Okay, I'll say this, learning about it, not as interesting. When you get to OChem, you'll start like doing reactions, you gotta sort of like think about like the stereoisomers, so like how the atoms are arranged in 3D space. So that part's interesting, like actually going 4 electron pairs tetrahedral, that part's not interesting.
Basically, what I'm learning is that this class is boring in comparison to OChem.
Pretty much, yeah.
But it's like, this class is very important for
Yeah.
OChem though, that's the thing. So like if you don't do well in the foundation classes like Gen Chem 1 and 2, you're gonna struggle in OChem unless you work your butt off.
All right,
So
I mean, I'll do that either way.
yeah. All right, people in the back, I'm gonna give y'all a special problem just for y'all. AlCl3. Determine the oxidation states this.
think in our heads. And then we'll have y'all say 3 what? For what? You said 3 plus for Al.
All right, indeed. What about chlorine? -1. And what do you call this compound? What do you name it as? It is indeed aluminum chloride, not aluminum trichloride like some people.
Aluminum, or not aluminum 3. Only because aluminum always has a fixed +3 charge.
Yeah.
Good
Not
job.
aluminum trichloride like some people have. All right. This one, what do you call this one?
TO.
Tin oxide.
Oh, no, wait,
That's
that's
what I call it.
titanium for oxide.
Titanium 4 oxide. It is titanium.
Okay, titanium for oxide.
Titanium.
Titanium 4 oxide.
Because oxygen, there's 2 oxygens. Oxygen has a charge of -2. Titanium needs a charge of +4 in order to balance it out.
That's one way to think about it.
Yeah. But there's also another route you could go down. What if this oxygen right here is peroxide? And it was titanium to peroxide. That could be true.
I mean, how would you know the difference in that case?
I don't know. It comes down to knowing the charges of titanium.
Oh, it can only have a charge of +1 or +2, can it?
I mean, I don't know about a +4 on the titanium, but I know +2 for sure is a thing. Like this was lead, I don't think you'd be able to tell the difference. Like it could be +2
Yeah,
or
'cause
+4.
you,
Same with tin.
Yeah. Anyways, let's assume it's titanium 4 oxide. Or,
Well, let's assume it's peroxide actually. All right, so what is oxygen's oxidation state if it's a peroxide?
hey, it's actually commonly +4. Titanium is commonly +4.
Interesting. All right, so let's assume it's a peroxide for 1 minute because I'm trying to teach you all one exception. So what is the oxidation state of oxygen in this case?
1 minus.
1 minus, right, because it's a peroxide. So -1, so what would our titanium be? +2. Now say this was titanium 4 oxide. What the oxidation state?
Then it would be +4.
Yes, +4 on here, -2 on here. Yeah, basically the point I was trying to get at is oxygen's always -2 except when bonded to fluorine, as you see in this case, or as a peroxide, where it's -1. And hydrogen, obviously +1 normally, but when bonds in metals, it's -1. Oh goody, we have more.
If y'all are comfortable with this, we could go through other stuff. I think there is more calculation problems.
Yeah, that might be the best use of y'all's time.
We might have to delete some before they. Yeah, how about you? There we go.
Y'all see nothing.
I'm sharing screen too, but I mean,
I think y'all memorize the answers like that. All right. Anyway, what's your number 11 because it's highlighted? Suppose a reaction between lead-2 nitrate and aluminum chloride solutions occur. What, James, what's the balance equation for this?
So PB.
So you're saying like this, PbNO3, 2, then what else?
AG, CL,
Ag,
I don't know, AL,
Al,
CO3.
Cl3, yeah. Now what does that make?
Let's see, so this makes PB. PbCl2, right?
Now what else?
And AL. NO3, 3. All right.
Yeah, Rami, right? Your name's Rami? Is this equation balanced, Rami? How'd you go ahead and balance it?
3 in front of the PB, 2 in front of the AlCO3, 2 in front of the aluminum nitrate, 3 in front of lead chloride. Lead.
3 here, and then 2 here. 3, 2, 3, 2.
Here.
All right, let's say 2 here, 6 here, 3 here, 6, 3, 3, 6. Yeah, works out. All right, what are our physical states?
Lead nitrate is aqueous, aluminum chloride is also aqueous. Lead chloride is solid and aluminum nitrate is aqueous.
Yep, right on the money. All right, now let's do some calculations. What volume of 0.250 molar lead-2 nitrate is needed to completely form a precipitate when added to 3.62 milliliters of a 0.35 molar solution of aluminum chloride? All right, how do we go about solving this?
It's the same thing as the other problems, right?
Pretty much. What do you gotta take into account here?
It's not we're looking for liters instead of moles.
Yeah, so we gotta change up our equation a bit. So molarity equals moles over liters. So what is our volume equal? Or if we solve this out, what is our, what am I trying to ask? So what is our,
if you algebraically
Yeah.
solve for L.
Yeah.
What is the equation?
Oh. Liters equals moles over molarity.
liters equals moles over molarity? Exactly.
That's what we're looking for. So we identified what we're looking for. And now we can identify what we're missing to solve for that problem.
Which is the moles.
Yep, or we need the moles first, so what are our moles of aluminum chloride in this instance?
So
One may need to sign into this.
1.267 times 10 to the negative.
So you said, okay, so 0.0362.
0.00362.
Yeah, it is. Thanks for that. 0.0362 times 0.35. So you will get 1 point, what was it?
1.267 times 10 to the negative 30.
Times 10 to the negative 30. Exactly. All right, so moles pretty much done, right? Now what do we need? It says lead two nitrate. So how would we get from moles of aluminum chloride to moles of lead two nitrate?
Or balance equation, molar ratio.
Balance equation. So for every 2 moles of aluminum chloride, there are 3 moles of EbNO3. And if you multiply this out, it's like multiplying by 1.5, you get 1.9005 times 10 to the minus 3 moles of PbNO3. 2. All right. Now we have everything we need, right? We have a molarity and we have moles. All that's left to do is plug into our volume equation. So we get this number 1.9005 times 10 to the minus 3 moles all over our polarity 0.250. And if we solve that out,
7.602 times 10 to the negative third liters, but it's looking for milliliters. So you multiply by 1,000 and you get 7.602. Well, 7.60.
10 to the negative 3 liters. This has got Rami right on the money. You get 7.6 liters. That's how you solve it out. All right, that's part B. Now, what mass of precipitate is formed? What do you have to consider for this problem?
Solve for the moles of or you have to find the limiting reactant first.
Exactly. You have to solve for your limiting reactant, because that'll actually limit how much of your precipitate you can make.
Is there a limiting reactant if you just found the amount each exactly required to react? See what I'm saying? Because we just found the moles of lead two nitrate that is exactly needed to react with the moles of aluminum chloride.
So they're not one.
They're both the limiting reactant.
Yeah.
So it doesn't matter which one you, but
So would that be the same thing with Alex problem I showed you?
Yeah, we're assuming that we have the exact like stoichiometric amount needed to create a precipitate in the first place.
so like if you need 5 of A and 5 of B to completely react to form 3 of whatever, then we have exactly 5 and 5. We don't have a limiting, or in this case, they're both the limiting reactor. Because that's just how this problem was set up. There's no limiting reactor.
So what we can do actually is we can take somewhat of a shortcut. So we found our moles, right, from the last problem of our lead to nitrate. So now what do we need to get it in moles of?
Lead or
What do
lead
we,
two.
yeah, but what do we know about the moles of lead nitrate in relation to lead two chloride?
They have the same molar ratio.
Yeah, so they have the moles of lead two nitrate are also that of lead two chloride. So 10 to the minus 3 moles of lead two chloride
It's multiplied by the molar mass.
is, you do indeed have to multiply by the molar mass. And I don't remember the molar mass for lead off the top of my head.
It's on the screen. On the
It is indeed.
1 mole of EbCO2.
So that out, you get 278.1 grams. Something I'd recommend doing when you're doing Alex problems, get a molar mass calculator. Like when I did my Alex problems, I Googled molar mass calculator, just put it on my elements and it will work. Or if I was feeling particularly lazy, I just put in all my molar masses to the nearest integer and then work from there. Yeah, some shortcuts. All right, so if you solve that out, you will get 0.529 grams of lead two chloride, EbCO2. With that, we went overtime by approximately 4 minutes. But yeah, session again, Monday, 5 p.m., same room. And
Be there.
or be icosahedodecahedron.
I don't even know what that is.
I know either, I just created a random shape.
All right, if there's no more questions,
Y'all are free to enjoy your weekend at this point.
make sure to do some chemistry over your weekend and start studying for your exam 2 yesterday. Okay, that's when we should have started studying first.
And I'll send out this review as well whenever we're done with it. We need to make some new questions and stuff.
You're welcome, Sophie. Have a good weekend. I gotta go make it. So.